Okay, so we're going to take a look at 14.1 practice C, number 6. It's asking us to graph a cofunction. And we do need to make the observation that this is the same as y is equal to 1 over the cosine of 2x. The way we're going to approach this problem is we are going to graphically create its reciprocal. We're going to do that by graphing cosine of 2x, and then basically taking every point in that graph and taking its reciprocal. So let's take a look at y is equal to cosine of 2x. Okay, so the first thing we want to do is identify the amplitude. Okay, since the a value up front is 1, we're going to go ahead and say that the amplitude for this guy is 1. And we're going to want to take a look at the period as well. Okay, the period is going to be 2 pi over the absolute value of b, which is 2. So this gives us a period of pi. All right, let's go ahead and create a coordinate plane. Okay, there's my terrible coordinate plane. Let's try that again. There we go. And on this coordinate plane, we're just going to make 4 equal divisions here for the period. So we'll split it up into 1, 2, 3, 4 equal parts, and we'll call that last part pi. Because of the fact that I split this up into 4 equal parts, this part right here is halfway between pi and 0. So this will be pi over 2. And this one is halfway between pi over 2 and 0, so this is going to be pi over 4. Because each of these is an equal piece, this is 1 pi over 4, 2 pi over 4, 3 pi over 4. Okay, so now I have the markings for my period and the values that I'm going to use to create my, my cosine graph. These would be my key points. Stated before, I have an amplitude of 1, so I'm just going to call this point up here 1, this point down here -1, and then I'm going to follow the basic cosine structure. Cosine starts at the top, okay, so there it is, and then it goes down to the bottom, back to the middle, and back up to the top, and that's one period of cosine. I'm going to go ahead and fill in the graph for that. So now we've got a graph of cosine. From this graph of cosine, we are going to create a graph of secant of 2x. Okay. So the first thing we want to do is take a look at some very special points on this graph. These are points where the cosine has a value of 0. Okay, looking at these points and the fact that the secant is 1 over the cosine of 2x, anywhere that I have 0 for the cosine of 2x, I'll end up with an asymptote because it can't divide by 0. So these points on my secant graph turn into asymptotes. And I've got an asymptote at pi over 4 and an asymptote at 3 pi over 4. The other key points that I'm going to take a look at are right here at the max and the min of the cosine function. Okay. Because this is 1, when I take the reciprocal of it, it stays 1. Because this is -1, when I take the reciprocal, it stays -1. And because this is +1, when I take the reciprocal, it also stays +1. Now what I'm going to do is make the observation that every single one of these numbers in between here and 0 is less than 1, but greater than 0. And when I take the reciprocal, they become numbers that are greater than 1. And it creates a function that arches up towards my asymptote. Okay. Over here, I'm making the same observation, only on the negative side. So all of these numbers are going to go down here. And the same is true of this side. And then lastly, on this side over here, I'll have the same property where these numbers arch up towards the asymptote, and same on this side too. So we'll go ahead and add a little tail. Okay, and now I've created a graph of y is equal to secant of 2x. Okay, and I did that entirely graphically based off of the co-functions graph and the simple reciprocals. So this is how we're going to go about making our co-function graphs.